Today we are looking at lesson 6.1, properties of exponents. So the essential question today, how can you write general rules involving properties of exponents? Now, before we can do anything and learn any rules, we have to know what a power is. I've given you the example of a power right here on the board. We read this 5 to the second power. But there are two things that make up a power. Does anyone remember what those two things are? Exponent. Which of the numbers is the exponent? The 2. All right. The little small one up here is the exponent. So if I am you in my notes, I'm just adding that little word exponent. So that leaves me with the 5. Does anybody remember what the 5 is called? The what? It is the base. All right. Now it's important that you know this because you're going to hear me say things like the base doesn't change. The base stays the same. Bring the base down, all right? You've got to know what the base is. The base is the large number, okay? It's the number being multiplied over and over and over again. And then, of course, you have the exponent. That's how many times you're multiplying the number. So this is a power. It's made up of a base and it's made up of an exponent. Now, the first rule I'm going to teach you is probably the simplest thing that I have taught you so far this year. All right, look at the zero exponent rule. Any number or variable raised to the power of 0 equals 1. So I want you to not only highlight the 0 exponent, but then I want you to go and I want you to highlight where it says equals 1. Because I don't want that to get lost. That is the point of the 0 exponent rule. Anything, any number, any variable raised to the power of 0 equals 1. Now, as with most things, there is an exception. 0 to the power of 0, okay, is undefined. So 0 to the power of 0 would be an exception to that rule. But if you plug 0 to the power of 0 into your calculator, it's going to say error, okay? And hopefully that reminds you that it's undefined. But other than that, any number, any variable raised to the power of 0 is equal to 1. Now, I've given you two examples. 10 to the power of 0 equals 1. So does y to the power of 0. Now, the negative exponent rule is not meant to be difficult, but it does tend to trip people up sometimes. So, pay attention to this rule. It says to change the sign of the negative exponent. So, to change the sign of the exponent, the negative exponent, but I need you to understand we're only changing the sign of the negative exponent. Let's go ahead and highlight negative as well. But to change the sign of a negative exponent, you move the power. So you're moving the entire power down to the denominator or up to the numerator. So it's going to depend on where the power starts off. If you look at the examples I give 5 to the power of negative 2. Where would you say that power is sitting right now? Numerator or denominator? It doesn't appear to be a fraction, which means I can make it a fraction by putting it over a what? 1. A 1. So absolutely 5 to the power of negative 2 is in the numerator, which means to change the sign of the exponent, I would have to move it down into the denominator. Now, what about 1 over 6 to the power of negative 3? Where is that power sitting? Denominator. So I'm going to have to move it up into the numerator. That will change the sign of the exponent only. Now, for today in our notes, we are going to draw arrows. I am not saying that you have to on quizzes and tests. I'm not even saying you have to on homework, but for the sake of our notes, you need to draw these arrows because if you want to go back and study and remember exactly what you did, the arrows are going to be super helpful. Now, let's go to example number 1 where it says evaluate the expression. We have talked about this before, but what does the word evaluate mean? Solve, okay? It's using the word evaluate because if you look at these 3 problems, what is the only thing involved in these 3 problems? Numbers or variables? No. Numbers. So when I'm working with numbers only, I can evaluate or I can solve because I can take these to a final numerical answer, all right? So we're using the word evaluate, which means to solve. Now, look at letter A. Let this be simple. Negative 9 raised to the power of 0. And it's negative 9 because negative 9 is in parentheses. So negative 9 raised to the power of 0 equals what? 1. That's it. You're done. There's no work involved. Anything raised to the power of 0 is equal to 1. So 1 is your final answer. Now look at letter B. Is that the 0 exponent rule, or is that the negative exponent rule? Negative exponent. This power sits where right now? In the numerator. So we're going to put it over 1. And what do we have to do in order to change the sign of the negative exponent? We have to move, not the exponent down, we have to move the entire power down. Now, when we move something and we completely clear out the numerator, in this case, what is left behind in the numerator? Because we still have a numerator, right? We're moving stuff down into the denominator. So what is left behind in the numerator? Not 0, because 0 divided by anything would be 0, okay? We are leaving behind the number 1. Very good. Now, when we move 3 to the negative third down into the denominator, what does it become? Give me exactly what I should write down on my paper. Exactly what it becomes. 3 to the positive third power. 3 to the third. 3 cubed. So notice, the base does not change. The only thing changing is the sign of the exponent. So by moving it down, I've changed it to 3 to the power of 3. Now, I have to keep going because it's asked me to solve. So, and this is just a reminder, what does 3 to the third power actually mean? 3 times 3 times 3. So add this in your notes. Again, I'm not saying you have to do this, but what if you're without a calculator? Or what if you don't want to bother with a calculator? This is pretty simple. So as long as I understand it's not 3 times 3, it's 3 times 3 times 3. What is 3 to the third power equal to? 27. So my final answer is 1/27. Now, I move to letter C. And listen, I'm always trying to teach you the first thing to look for to help you. The first thing I am always looking for is something raised to the power of 0. Because if I see something raised to the power of 0, I can go ahead and cross it out and replace it with what number? 1. Okay? So, before I do anything, what do you see in this problem that I can do first? Change, simplify, what do you see? All right. Now, be careful because she says make -5 to the 0 power 1. But do you see how the -5 is not in parentheses this time? Okay. So the negative is actually not going to go anywhere. It has to stay. All right. You read this, and this might be a good extra note to add. You actually read this numerator as the opposite of 5 to the power of 0. So what is the only thing we can cancel? Not the negative, but we can cross out 5 to the power of 0. What does that equal? Hold on, just 5 to the power of 0. That equals 1. So when I cross out 5 to the power of 0 and I replace it with a 1, now, yes, what would I bring down? What is now in my numerator? -1, and of course I would bring down 2 to the negative second power. Now, if you go back to the directions real quick, it not only says to evaluate the expression, but do you see the second part of the directions? It says use only positive exponents in your answer. So, am I allowed to stop and box in this as my final answer? No. And I can't do 2 to the power of -2. How would I figure that out? All right, you can't have negative exponents here. So what do I need to do next? How do I change the sign of the exponent? I move it up into the numerator. Now again, we're using arrows in our notes. So I bring down the -1. I can't get rid of the -1. If it was just a 1, it would be okay for it to kind of go away, but it's a -1, so we got to keep it. What happens to 2 to the -2 when I bring it up into the numerator? It becomes, give me the whole power, 2 to the second power, 2 squared. Okay, now let's think about this for a second. I have just moved 2 squared up into the numerator, and there was already something up there. So what do you think I need to do to those two things? Add, subtract, multiply, or divide? I need to multiply. So I do a little bit of math. -1 times, what is 2 times 2? Remember, 2 squared means 2 times 2. And what does that equal? 4. And then what's -1 times 4? -4. You say, Ms. Johnson, do I have to show all this work? Okay. Yes, because there's not a lot of work to show. So if you accidentally put a wrong answer, like you accidentally put a +4, it's very difficult for me to give you partial credit because I can't see where you went wrong. All right, so it's not a whole lot of work. That's the beauty of exponents. It's not, not a whole lot of work, but there is some work to show. Now that brings us to our next 3 rules. All right, we have the product of powers property, we have the power of a power property, and we have the quotient of powers property. So let's start by looking at the product of powers. This is when you are multiplying powers with the same base. So this is important. You're multiplying 2 powers, and those 2 powers have the exact same base. So here's what we're going to highlight. We're going to highlight the name of the property, so product of powers, and here's how you do it. You add the exponents. If you are multiplying 2 powers with the exact same base, you are actually going to add the exponents. Now, I gave you the example of 2 squared times 2 to the 3rd. All right, so let's talk about, do you see anywhere in this definition where it says change the base? Or does it just say add the exponents? Just add the exponents, right? So the base will not change. What is the base in this problem? 2. So we keep the 2 and we simply add the exponents. So that means we're adding 2 plus 3. Again, Ms. Johnson, do I have to show the work? Yes, because you know what? You know what I did earlier today? This is what I wrote down. 2 to the 6th. What did I do in my head? And what was I supposed to do? So if this is my test, my teacher can see, oh, she knew to add 2 and 3, but she just accidentally multiplied. So I take off a point. All right. If this step is missing and all I see is 2 to the 6th, how can I give you partial credit? I don't know where you went wrong. Okay. So you see why it's important that you show me that you understand 2 plus 3. And of course, what is 2 plus 3? 5. But that's all you do. You keep the base the same. You add the exponents. Then we have the power of a power. The power of a power. And I like the power of a power because look how you work it. This is when a power is raised to a power. So if you go to my example down here, I've got 5 squared in parentheses. So 5 to the 2nd power. And then that is raised to the power of 3. So it's a power raised to a power. But look at what you do. You multiply the exponents. You say, Ms. Johnson, how am I going to remember when to add and when to multiply? Well, since I learned this back in the 8th grade, here's how I've always remembered it. What is the only thing separating those 2 exponents? A parenthesis. And what operation does a parenthesis go with? Multiplication. You say, but up here, okay, up here, there is a base between the 2 exponents. Okay, it's kind of like a barrier. But down here, the only thing separating the 2 exponents is a parenthesis. So hopefully you can easily remember the base stays the same and you are multiplying 2 times 3. What is 2 times 3? 6. So 5 to the 6th power, or 5 to the power of 6. Now, the last one we're going to look at right now is the quotient of powers. Now, the quotient is the answer to what kind of a problem? Go back to elementary. A division problem. So this is when you are dividing powers with the same base. And just for a minute, go back to the first one. I forgot to mention this. The product is the answer to what kind of a problem? To what? Multiplication. Okay? So the product of powers property is when you're multiplying powers with the same base. The quotient of powers is when you're dividing powers with the same base. What is the rule when you are dividing powers with the same base? What do your notes say? Subtract the exponents. You say, okay, how am I going to remember this one? Again, since I learned this back in the 8th grade, I have always let the fraction bar remind me to subtract. So my base, again, does not change. What is the base in this problem? Okay, this rule only works if the bases are the same. So 3 is my base, it stays a 3, and I take the numerator exponent minus the denominator. So what is 3 minus 2? 3 to the 1st. All right, now let's focus on these 3 rules. Example 2. Now notice they changed from the word evaluate to the word simplify. The only reason they're doing that is because now your problems involve what? Not just numbers, but they also involve what? variables, okay? And we can't go all the way. We can't get rid of variables. So we only are going to be able to simplify. But we will continue with the numbers to go as far as we can. You will also notice in the directions that once again it says, write your answers using only positive exponents. Now, as a group, I want you to decide when you look at letter A, which of the three properties we just mentioned do you think we're going to have to use? Now, grab your highlighter. What's the very first thing I've told you to look for over and over again? Right off the bat. Okay, do we have an exponent of 0? Yes, right here. So, in your notes, highlight it. And what is y to the power of 0? What does it equal? 1. So again, I am fine if you cross it out and just put a 1 beside it, underneath it, to the right of it. I don't care. But just show that y to the power of 0 cancels and becomes a 1. All right? Now, what do we do next? We're not allowed to have any negative exponents in our answer. We can't do 3 to the negative second. So what do we do next? What would be our next step? Bring what down? All right, be careful because we're not just bringing down the negatives. We're bringing down the entire power. So, Kiana, what are we bringing down first? The negative powers. Okay, but give me the power. 3 to the negative second. Okay, we're going to bring down. So, again, remember we're doing arrows in our notes. So, keep doing arrows. We're bringing 3 to the negative second down. Okay, or 3 to the power of negative 2 down. And what else are we bringing down? Okay, x to the negative fifth. Now, we have once again cleared out the numerator. So what are we leaving behind in the numerator?
1.
A 1. And what is now in the denominator? 3 to the second and x to the fifth. So you see how the 1 is positive, so it can kind of just disappear. All right, 3 to the negative second becomes 3 to the second. X to the negative fifth becomes x to the fifth. Now, is there anything else we can do? Have we simplified it as far as we can? No, because we can still do what? We can still do the 3 squared, right? So, 1 over, what is 3 squared? 9, because 3 squared is 3 times 3, and then x to the fifth, and this would be our final answer. Letter B, we're doing the product of powers rule, which says, when you're multiplying powers with the same base, what are you supposed to do? Add the exponents. So what is the base? And it is not changing. And we are supposed to add the exponent. So 4 plus negative 6. Now notice I put negative 6 in parentheses so that I don't have a plus and a minus side by side. But do the math. What is 4 plus negative 6? So 10 to the negative second. Now, can I go any further with it like this? No. So what do I need to do? KK, with 10 to the negative second. Okay, but what am I going to do with it? Okay, now she used the word flip, which I'm actually glad she used. That's not a word that we want to use, all right? Here's why. Flipping entails taking and switching like a reciprocal, okay? We are moving things because sometimes we don't have to move everything in the numerator. So we don't want to get in the habit of saying, oh, you just flip it. No. You move the power up or down, okay? So what exactly are we moving? First of all, this doesn't look like a fraction, so I need to put it over what? 1. Okay. Now, KK, where am I moving 10 to the negative second? I'm going to move the entire power down. So KK, what did I leave behind in the numerator? 1. A 1. And now in the denominator, I have what? 10 to the second power. Am I finished? No, I can finish this because what is 10 squared? 100. So my final boxed in answer is 1 over 100, or 1/100. Now look at letter C, okay? Before we do anything, show me the rule that we're using on this one. Using the quotient of a power. Now, before we even get into that, though, I want you to look at the original problem. This is a fraction, right? And we can actually look at this problem and we can right off the bat make a change. What happens when you divide a negative by a negative? Let's go ahead and make this positive and positive. That way we're not dealing with any negative numbers. All right? Now we can apply the quotient rule. The quotient rule says when we're dividing powers with the same base, we do what to the exponents? Subtract. So the base is going to stay a 5, right? and we are supposed to subtract 8 minus 4. So what is 8 minus 4? 4. Now, again, be very careful. What does 5 to the 4th power actually mean? It does not mean 5 times 4. It actually means what?
5 times 5 times 5.
5 times, good. 5 times 5 times 5 times 5. So, what is 5 to the 4th? 625. Perfect. All right. Work letter D, E, and F with your partners. What property did you use for letter D? The quotient. So you were supposed to do what with the exponents? So you had y, and then you had 6 minus 7. Well, what is 6 minus 7? Negative 1. Were you able to stop there?
No.
What'd you do next? Okay, you put the power over a 1, and then what? You moved it, meaning the power, okay? Which left you with a what in the numerator?
1.
A 1, and what in the denominator? Y to the first. Now, do you have to put the 1 on the y, or can you leave it off? You could leave it off. You can put it, you can leave it off. It doesn't really matter. All right? Now, letter E. What property are we dealing with in letter E? Power of a power, all right? Because we see there is 6 to the negative 2nd power, and that is all raised to the negative 1 power. So right here, what are we supposed to do with the exponents when it's a power raised to a power? Multiply. So negative 2 times negative 1 gives me 6 to what power?
2.
Which equals 36. Awesome. How many of you had 36? Great. And then letter F, what was the property you used? Power of a power again. So you had to do what with 12 and 5? And that gave you a final answer of? W equals 60. All right. So some of these are going to be super quick. All right. As long as you know the properties and the rules, some of these are going to be super quick. But now we get into the most complicated of the properties. There's 2 left. This is the power of a product. So you see the words are kind of the same. So this is a variation of the power of a power. All right. Because you've got the power of a product and the power of a quotient. So let me make it simple for you. This is when 2 or more numbers or variables are being multiplied inside of your parentheses. So look at the example that I gave you. What is being multiplied inside the parentheses? 2 and x to the 4th power. Okay, so instead of just having one thing in the parentheses being raised to a power, you now have 2 or more. All right? Then go look at the power of a quotient. This is when a fraction is raised to a power. Again, go inside the parentheses. What is inside the parentheses here? X divided by 4. So you have a fraction inside of the parentheses. So you no longer get to apply that outside exponent to just one thing. You actually have to apply it to everything inside. So when it says find the power of each factor and multiply right here, essentially what it's saying is apply that exponent to every exponent on the inside. Now you say 2 doesn't have an exponent, but does it? Anything, any number, any variable without a visible exponent has an understood what with it? There is an understood 1 right there. So you are going to do 3 times 1, and you are going to do 3 times 4. This is the power of a product. You apply the exponent on the outside to all of the exponents on the inside. If you go to the power of a quotient rule, it says find the power of the numerator and the denominator and then divide. Okay, same thing. X is raised to what power on the inside of these parentheses? 1. A 1. And 3 is also raised to the power of 1. So I apply the 4 on the outside to the numerator and the denominator. Let's put this into practice. Example 3, again, says simplify the expression. We're using simplify because there are numbers and variables in the problem. Again, it says write your answer using only positive exponents. So make sure you're paying attention to that as well. All right. Which rule are we going to apply in letter A? The power of a product or the power of a quotient? power of a product, because in the parentheses, we are multiplying two things. Okay? So 10 has an understood exponent of 1, and y has an understood exponent of 1. So when we raise that to the power of -3, what do we get? 10 to the -3rd and y to the -3rd. You're like, Ms. Johnson, how did they do that? Because remember the power of the power rule? We multiply the exponents. So 1 times -3 is -3, and 1 times -3 is -3. Now, are we allowed to stop here? Are we allowed? No. What do we got to do first? Okay, well, we got to put it over 1 and then decide what we're moving. What are we moving this time? 10 to the -3rd. Is that it? And y to the -3rd. They both have negative exponents, so they both have to move. What does that leave us in the numerator? 1. And what happens in the denominator? What do we now have in the denominator? 10 to the 3rd and y to the 3rd. Are we done? No. Michaela, we get 1 over what? If we flip it, it becomes 10y. All right, now we keep it in parentheses. By flipping the fraction on the inside, we now are able to change the exponent on the outside to a +3. Now we're going to do exactly what we just did, but with a +3 instead of a -3. So the 1 that we now have is 1 raised to what power? No, not on the inside. We're still looking at it right now on the inside. It's 1 to what power? 1 to the 1st. 10 to the 1st. Y to the 1st. So when we apply the 3, we're applying it to every single exponent on the inside. So that becomes 1 to the what power? 3rd power over 10 to the 3rd, y to the 3rd, and then we just do our math. 1 to the 3rd power is 1. 10 to the 3rd power, we already know, is 1,000. And of course, y to the 3rd stays y to the 3rd. So did we get the exact same answer? Yes, we did. All right. So you can keep the -3 out there and you can apply it to everything, but then you have to do a whole lot of moving. Or you can take the fraction, flip it, and go ahead and change that outside exponent to a positive number. All right. Now let's move on to letter B. Now there is a negative sign in front of the fraction. We're just going to go ahead and bring it down. Okay. We're just going to keep it in front of our answer. 4 right now is raised to what power? Okay, and n is raised to what power?
1.
So when we apply the 5, when we raise it to the power of 5, Dorian, what do we get now? 4 to the 5th and, or over
4
to the 5th. Very good, because again, and if you need to keep drawing these arrows until you get it, keep drawing the arrows. We apply the outside exponent to all of the exponents on the inside. And we're multiplying because this is a power of a power rule, essentially. Okay? Now, can we move forward with this one, or is this our final answer? We can keep going, because what is 4 to the 5th power? 1,024. And of course, we cannot do anything else with n to the 5th. So negative 1,024 over n to the 5th is your final answer. All right, look at letter C. Let's keep moving. Letter C. 1 is raised to what power? 1. 2 is raised. And this is where people mess up. They don't tend to look at 2k squared. They don't look at that as a 2 and a k squared, but you have to. Every number, every variable is its own thing, its own term. So that 2 is raised to what power? 1. And of course, k is already raised to the power of 2. All right? So, Talon, tell me what we get when we apply the 5 to all of the exponents on the inside. While she's thinking, what property are we using on this one? Power of a quotient, because it is a fraction inside of parentheses. All right? What do we get? 1 to the, if you just say 1, 5, that's what I'm going to write down. So make sure you read the powers correctly. It's 1 to the what power? 1 to the 5th power. Okay, over. You got to apply the 5 to every single exponent. Remember, 2 has an exponent of 1 right now. So what do I get when I multiply the 5 and the 1? Okay, so 2 to the 5th power. Keep going. K to the 10th. Remember, the power of the power rule says we multiply the exponents. So that's what we're doing. All right? What is 1 to the 5th power? 1. What is 2 to the 5th power? 32. And then, of course, we keep the K to the 10th. We have no negative exponents, so that is our final answer. All right, now look at letter D. What do you notice right off the bat about that exponent on the outside?
Negative.
It's negative. So take your highlighter and highlight it, because from now on, when we see that in class, we're going to do the shortcut. The shortcut says I do what with the fraction inside the parentheses? If not already, make yourself a note next to the 2 shortcut problems. Tell yourself, I'm going to flip the fraction inside the parentheses. So when we flip this fraction, what do we get? 7 over 6c. All right. Once again, that now makes the negative 2 on the outside a positive 2. All right. Now, 7 is raised to the 1st power, 6 is raised to the 1st power, and c is raised to the 1st power. So what does that give me when I apply the rule? 7 to the 2nd over 6 to the 2nd, c to the 2nd. And then we do a little bit of math. What is 7 squared?
49.
What is 6 squared? 36. And of course we bring down the c squared. Now, it is a fraction. There's a number in the numerator and the denominator, so we have to see if it reduces. Does 49 over 36 reduce? No, it does not. So this is our final answer. Now the last problem, the last example says write your answer in scientific notation and standard form. So this is kind of the word problem that we're going to use to go along. This is scientific notation, but we're fixing to have to apply a bunch of different rules that we just learned. All right, but we're going to keep this simple. This one happens to be a division problem. So we are going to divide the decimals, and then we're going to divide the powers. All right, so grab your calculators. What is 2.3 or 2 3/10 divided by 2 5/10? 0.92. And then times, what is 10 to the 8th? Now, which rule are we applying here? It's 10 to the 8th divided by 10 to the 2nd. So what are we supposed to do to the exponents? Subtract them. This is the quotient property. So we're going to take 8 minus 2. And again, we are showing all of our steps. So 0.92 times, what is 8 minus 2? 8 minus 2 is 10 to the 6th. It's 6. Sorry. Yes. Okay. Now, if you can think back to scientific notation, how many numbers are supposed to be in front of the decimal when we're doing scientific notation? How many are in front of it right now? 0. So, how many spaces are we moving the decimal? 1. So now we have 9.2 times 10 to what power? Because we just moved that decimal back 1 space. Is that a positive 1 or a negative 1? Negative. Remember, moving decimal. That's what the exponent is about. Moving the decimal. So we moved it back 1 spot. So we now have 9.2 times 10 to the negative 1st. But we also need to bring down the times 10 to the 6th. So here we are again. What property are we going to use right here? Okay. Product, power of a power, or quotient? This is product. You're multiplying 2 powers with the same base. So we get 9.2 times 10 to what power? The 5th. Because, again, let's show the work. My negative 1 plus 6. So 9.2 times 10 to the 5th. Now, that is the answer in scientific notation. We now have to put it also into standard form. All right, standard form says we take the 9.2 and we move the decimal 5 times, right? The exponent is 5. So watch, we move it once, twice, 3 times, 4 times, 5 times. What do we fill the egg crate with? Zeros. So standard form is 920,000. So we now have it in both scientific notation and standard form. That is lesson 6.1.